What if the very thing that makes us human, our conscious experience, isn't located in one single spot in the brain, but is actually a dynamic dance between two distinct regions? For centuries, philosophers and scientists have debated where consciousness resides, but a groundbreaking shift in 2026 is finally turning that debate into hard data. Today, we are diving into the latest research that pits two leading theories against each other, revealing a surprising anatomical divide that could redefine how we understand our own minds. Stay until the end because the answer isn't just about where consciousness happens, but how this discovery will revolutionize artificial intelligence and medical diagnostics. For a long time, the study of consciousness was trapped in a philosophical fog. We knew what it felt like to be aware, to see the color red, or to hear a melody. But mapping those subjective experiences to physical brain activity proved incredibly difficult. The field was dominated by isolated confirmatory studies that often spoke past one another, leaving researchers with more questions than answers. The core problem was a lack of empirical adversarial testing. Without directly pitting competing frameworks against one another using rigorous data, we couldn't tell which theory actually held the key to the mind. This mattered because without a clear target, efforts to diagnose disorders of consciousness like coma or anesthesia were limited to behavioral observations, rather precise biological markers. We needed a way to move beyond abstract definitions and find the actual neural signature of being aware. Now, a major methodological shift is changing the game. Researchers are no just describing consciousness. They are actively testing it using multivariate pattern analysis to falsify competing models. Two heavyweights have emerged in this arena: the Global Neuronal Workspace theory and the integrated information theory. Imagine the brain as a vast, bustling city. The Global Neuronal Workspace theory suggests that consciousness is like a central broadcast system, where information is shared globally across the entire city, with the prefrontal cortex acting as the main control hub or the city hall. It posits that a neural state becomes conscious only when this information is made globally accessible to multiple brain systems. On the other side, integrated information theory argues that consciousness isn't about broadcasting, but about integration. It identifies a reentrant architecture, systems with internal recursive feedback loops, as the necessary condition for awareness. Think of this as the city's local neighborhoods, where deep, complex interactions within specific communities create the richness of experience. When these theories were finally subjected to direct adversarial testing, the results were startling. The data revealed that these two frameworks make distinct, testable predictions about where in the brain we should find conscious content. The Global Neuronal Workspace uniquely identifies the prefrontal cortex as the critical hub for global access. Meanwhile, integrated information theory accurately predicts that the maximal decoding of conscious content happens not in the front, but in the posterior cortices, the parietal, temporal, and occipital lobes. This is the posterior hot zone. It turns out that while the front of the brain manages the access and coordination of information, the actual phenomenal content of our experience, what it feels like to see or hear, is rooted in the back. This synthesis moves the field from a philosophical stalemate to a concrete understanding of a synergistic workspace, where consciousness is defined by the specific dynamics of information flow between these distributed networks. The implications of this discovery are profound and far-reaching. For neuroscientists, identifying the posterior hot zone as the content-specific correlate provides a precise target for high-resolution neuroimaging, potentially accelerating the mapping of the human mind. For clinicians, this offers a new way to look at disorders of consciousness. Instead of relying solely on whether a patient responds to a command, doctors can now look for the breakdown of synergistic information integration within these specific networks to diagnose conditions like coma or the effects of anesthesia with greater accuracy. But perhaps most excitingly, this has massive consequences for artificial intelligence. As we race toward creating AGI, the distinction between reentrant architecture and simple feed-forward processing provides a structural blueprint. It gives developers a criterion to distinguish between AI systems that merely simulate consciousness and those that might possess genuine awareness. This guides the ethical framework for building machines that could one day truly understand us. So, the mystery of where consciousness lives is no just a question of philosophy. It is a map of our biology. We now see that our awareness is a dual process, anchored in the posterior regions for content and orchestrated by the prefrontal cortex for access. This convergence of theory and data marks a pivotal moment in our understanding of the mind. What do you think about this split between the front and back of the brain? Does it change how